One of the most important characteristics to understand about satellites is the various satellite orbits. So there's various ways in which the satellite orbits can be defined. One way is to define it by altitude, how high above the surface of the Earth the satellite is moving. There are low Earth orbits, which are 0 to up to 2,000 kilometers above the surface of the Earth. There are mid-Earth or medium Earth orbits that are between 2,000 and approximately 35,786 kilometers above the surface of the Earth. And then the reason that's such a specific number is right at approximately 35,786 kilometers above the surface of the Earth. That's where the geosynchronous orbits are. And the geosynchronous orbits means that the satellite is moving at the same speed that the Earth is rotating. And above those, we would have the high Earth orbits above the geosynchronous orbits. So that's one way to describe them, just by how high up above the surface of the Earth the satellites are. Maybe a more useful way, as far as understanding how the images piece together or what they look like, is to describe the orbits as the orbits that are geosynchronous as either sun synchronous or geostationary. And I'll talk about what both of those mean. A sun-synchronous orbit is one in which the satellite is rotating around the Earth. It's revolving around the Earth, and this would be its orbital track shown here. So it's not quite crossing the North Pole, and it's not quite crossing the South Pole. And as we'll see, it's kind of inclined at an angle of about 9 degrees. And so the satellite just keeps orbiting the Earth like this. And the reason it does that is because the angle of the sun on each of its orbits stays consistent, so that everything is consistently lit from scene to scene. And even when it comes back days later, it's still consistently lit from scene to scene. So these sun synchronous orbits are basically trying to take advantage of keeping the lighting from the sun the same. And as we can see here, right, we're going to have to account for the Earth's rotation, because the Earth is going to be moving underneath the satellite as it keeps orbiting in these sun-synchronous orbits. So as I said, that angle of inclination is about 9 degrees from going right over the North Pole and the South Pole. And the reason for this is because of the equatorial bulge. And if it did go right over the North and South Pole, it would not stay sun-synchronous because of that equatorial bulge. So it just has to be at a slight angle to that in order to make everything work out. And because it is at an angle, we get these images like this. This is the first image from Landsat 7 when it was launched. And the edges of it do not align directly with north and south, because this is how the satellite was passing over. It was passing from north to south, but not directly north-south. It was at a 9-degree angle from north-south. So a lot of times when we see satellite images, if north is to the top of the page, they'll just be tilted like this because of that angle, representing how the sun-synchronous orbit is not going right over the North and South Pole. Maybe an easier one to understand is the geostationary orbit. So that would be the one shown by this kind of belt type thing here. This would be a satellite that's orbiting the Earth at just the exact same speed that the Earth is rotating. In this example here, this satellite, this geostationary satellite in geostationary orbit, would stay at the equator, would stay right exactly above that point on the surface of the Earth that is trying to observe. So this is really good for things like weather satellites. If a country is concerned with its changing weather patterns and always wants it to be in sight, whether all of the time that the satellite is up there, it can choose this sort of geostationary orbit. And of course, with these geostationary orbits, you're getting a view of the Earth where you're always viewing the same location on the Earth. It can be night or day. Various clouds can roll in and roll out, but you're always viewing the same area because the satellite is orbiting the Earth at the exact same speed that the Earth is rotating on its axis, so it's always kind of stayed in that same location. And these are the ones that are that specific distance above the surface of the Earth, taking into account the advantage that the Earth is rotating at exactly its orbital speed.